Hi, my name is Mohammed Ahmed. I'm the Chief Technology Officer at ClearNav. I worked in the integration of custom PCB and hardware integration at ClearNav.
My name is William, and I'm a computer engineer at ClearNav, and I worked on the software systems.
My name is Spencer, and I am the Chief Operations Officer at ClearNav, and my role was to do the front-end application as well as the GPS component of the product.
Hi, my name is William. I'm the Chief Executive Officer at ClearNav. I did the 3D CAD designs and all of the 3D printing.
Hi, I'm Namsaki, the Chief Financial Officer at the ClearNav. I contributed in the branding of the product and an interlock mechanism for the hardware.
Hi, my name is Samoor Ahmed and I'm the Chief Design Officer at ClearNav. I helped the team with the hardware and worked in designing the PCB.
So the motivation for us at ClearNav for EZhud is to reduce two major problems faced by motorcyclists. Number one, motorcycles are risky and they're overrepresented in road accidents according to ICBC statistics. Number two, unlike cars, there's a lack of infotainment system in motorcycles. So EZhud, we propose to EZhud to solve the problem as it comes in with a built-in navigation, a GPS to display live speed, and also to document the adventures. It comes in with a dash cam. So you don't have to look down while driving and you can focus on the road ahead.
So our purpose at ClearNav is primarily to help the motorcycle community in making their ride safer. We also want to just build products and technology that are easy and fun to use. And lastly is all the big automotive companies are beginning to add heads-up displays to their cars, and we feel that it's necessary to bring the same technology but to the motorcycle market.
So guys, let's go on a ride with our product EZhud. So this is our product. On the bottom we have our USB port, our display port, and our charging port. So once we connect the charging port, you can see the charging light over here. We have a power light and a low battery light. So let's just remove the charging right now, and this is the power button. I'm going to turn on the EZhud, and let's just connect it. We have our locking mechanism over here, so let's just slide our inside, and then I'm going to lock it. We're going to have to connect our display connector. Once that's done, I'm going to wear the helmet. So once you wear the helmet, you can adjust your display. Looks good now. And let's go to our phone. So on our phone, in our app, we have our dash cam footages over here, and they are assorted with the dates. And we have our settings where you're gonna go and connect the EZhud to your phone, and this is our search bar. Let's go to downtown. Once that's done, you can keep your phone back to your pocket. And yeah, I can see it. Now I'm ready to go.
Hi, so let's talk about some of the limitations, future works, and assumptions. One of the main limitations is that it is currently a wired product in which we can get it into a wireless mode. However, there are some software issues. It doesn't work in rain. We need some further work in our seals. We need mobile data to get the app started, as well as the built-in GPS has some functionality limitations underground, and we can't change the route while we're riding. We need to stop, pull over, and then change the route. It doesn't work with certain types of helmets which do not have a side mount to adjust our mount, and it currently only works on Android. In terms of maintenance, we can replace the SD card and the battery after a long time, but it will need to be done by ClearNav staff.
Right, so as mentioned before, normally in operation we'd be using the viewfind display instead. So here's a view of what you would see when wearing the helmet. So right now we're looking at open dash, and we can switch to the GPS mode, and we see that right now we have a weak signal because again, no fix in SFU. So going back to the navigation mode, once I plug in my phone, we should see Google Maps show up. Like so. And now, if I start a route to, let's say, the Hard Rock Casino in Vancouver, navigation begins.
Presented here are some of the technical details of our project. Shown here are electronic components outside of the case, including the button board, DC-DC boost, the GPS, the viewfind PCB and display, the battery, and the Raspberry Pi I/O board. Here we can see that the entire outer shell is designed in Fusion 360, including the camera hole in front, the top detachable lid, the display, power, USB connectors on the bottom, the helmet attachment clip, and all the internal electronic components. All the components fit nicely into the case with PCB mounting pegs for each one of them. The CM4 compute module sits opposite to the GPS and the DC-DC boost circuit. A display connector is created and attached to the top lid of the helmet with Velcro. A ball joint is also apparent in the design to allow the user to adjust the display position. The display comes from a viewfind off-the-shelf display product in which we soldered the battery off, then soldered it to our main 6K mAh battery and connected the power button to an onboard Raspberry Pi GPIO pin. Upon boot, the Raspberry Pi toggles the viewfind PCB on-off button to turn the display on. Shown here is the flexibility of the ball joint for the rider to adjust to their comfort in front of their eyes. A PCB design is also completed during the duration of this project. Individualized connectors aren't necessarily designed, including the CM4 Heroes connector, the GPIO pins, the SD card slot, the USB port, the HDMI port, and the camera CSI connector, and the JST port. Unfortunately, due to insufficient time, the design was not shipped out. The front-facing dash cam is shown in this slide. Recording starts on boot, and a button is there to start and stop recording. The videos are available on the device web server. An acrylic plate protects the front-facing sensor of the camera. A GPS is also present which tracks the rider's speed. Shown is the motorcycle helmet attachment mechanism in which the main device connects to. The device attaches the helmet using VHB tape. A sliding lock is implemented which locks the device onto the helmet. Here is the final assembly of the device and the ClearNav company group. Thank you for watching.